Hello, friend. Hello, friend. Hello, friend. Hello, friend. Hey guys, this is Avi from musicalengineering.net. I just wanted to create a really simple tutorial, really short, really simple tutorial on the single most powerful tool in an audio engineer's arsenal, the equalizer. So let's just take a look. We're here in just like, the project field. Now there are two ways to open the equalizer. If you want to open the stock channel EQ, which isn't like the linear phase one, basically this is the one that you're going to be using during the dirty mixing work. The main difference between the two, I'll even show you them right here. Look at this. Between the channel EQ and the linear phase EQ. I don't actually know the specifics, but this one colors the sound more, which is what you want when when you're mixing and you're doing your engineering and you're recording. But when you are say you're mastering, you're doing post-production, something like that, you're gonna want to move over to the linear phase EQ because that will not color the sound as much. So you can almost say that it's almost more pure in that it's taking out just the sound you want it to. But that color that you get on the channel EQ is part of what makes it sound so good during the mixing process. So I would definitely not recommend only using the linear phase EQ. In fact, the linear phase EQ uses more processing power because of that. So the channel EQ is amazing and works great. These other two, maybe we'll talk about it in a different time. But for now, let's just, you can open up the channel EQ just by clicking this EQ section right here. This is on the stereo out though, so this is great to say in a tutorial. We never, ever, ever, ever want to put anything out on this stereo out master bus. This is our master bus, our master fader. Always keep it at 0. Never put anything on there. Sometimes I would put an EQ on the mix box here, and basically what this is doing, this is great because right here you're actually see, this is exactly what I was talking about. When you have the analyzer enabled here, when it's highlighted like that, it's enabled, so like that. Analyzer, post. And there's even this little button here. So this analyzer button is going to show you an okay representation of the sound wave as it's happening across the frequency spectrum. So you can see that the main aspects of my voice is sitting down here in the hundreds, but you have overtones coming up here in the thousands, and my S's are right here in the 5, 6, 7K range. In fact, even up here into 10K too. Yeah. Anyway, this is your basic channel EQ. This comes stock with Logic. When you buy Logic in the store, in the App Store, this comes with it. Pro Tools also has a great stock EQ. Any DAW, any digital audio workstation is going to come with a stock EQ that's going to be great for anything you're going to need to do with it. There are still pros out there that, will just pop out a stock EQ just because it does its job and does it well. Basically, we have our frequency spectrum here. Our x-axis is the actual frequency itself, and our y-axis here is our gain. There's a little gain knob here that we can use to go up or down. But generally speaking, it's best to just keep that at 0 and use different and solitary processing for gain. There's actually a gain plugin, which is great for gain staging. But I suppose you could feasibly do gain staging with this knob as well, right in the EQ. So good for Logic for making stuff really easy and putting options everywhere, because that is one thing that DAWs will give you, is tons of options on how to do generally the same thing. And it's not really about doing it a right way. There are some general rules of thumb you do want to follow, but you want to make sure that you are doing things in a way that flows, that works with your work style. So I'm now recording my voice into Logic. This is how I'm doing my screencast here. And what you're seeing is a wave representation across the frequency spectrum of my voice. And as you can see, no aspects of my voice is peaking past 0, which is good. It means we're not clipping or anything. But we're getting close a little bit. But that's good. We want to keep it below 0. So this is our spectrum. We can use specific kinds of tools and move them across the spectrum. They try and put some here. These are, I guess, putting some presets or something. Let's just recall the default. It should be okay. So this is our high pass filter. It does exactly what it says it does. It lets anything above a certain marker in the frequency spectrum pass through. Anything that is below that mark will not pass through, as you can see by this large red area. This is the suppression area. The way it's set right now, it's at 95 hertz, so nothing below 95 hertz is being heard. Now, if we move it down, we can simply drag it like this. Now we're at 49 hertz. And as you can see, where there wasn't information coming in below 95 hertz, now there is. Now there is information down there. And let's even bring this up to 500. Look at that. You can't hear anything below 500 now, or I guess nothing below, what is that, probably 400, thanks to this little line. This is the dB over octave line. So this basically is giving us the slope of how much we're toning down on the filter. So how hard is this filter? We can make it less intense. This is the most intense it could be. But if we turn it up, there we go. There, see that? That's a much less dramatic filter there. It's a lot more steady. You can see information coming in at 100 hertz right here, and even a little bit below. And as you go up more, that's 36, you can see that slope gets a little easier, lets in a little bit more information, more and more and more. So that's our low pass filter. The next thing I'm going to look at is our shelf filter. Now our EQ shelf tool here, this basically takes something and boosts it or cuts it. Cuts, boosts. So this shelf filter can come in handy if we want to take everything, say, at 58 hertz. We don't want the muddiness that can come around the 200, 250, 300 hertz area. We don't want that muddiness, but we want, still some bassness in there. So we can put this up on 8 dB is a lot, but that's what you can do with it. That's our shelf filter. Now these are our bell curves. Now what these do is they are what they say they are. They are bells. And this little symbol, these symbols come from the two directions that they can go in. So if you notice, if you do that, and you can get another one here, you can literally create a symbol. See? There you go. So you can do it in a bell like that. So these are basically, this is the same thing, but we have a high shelf versus our low shelf here. And at the very end here, we have our low pass filter, which basically is the exact opposite of a high pass filter. Anything set below this marker is going to come through, but anything after this marker is not going to come through. Anything below the threshold, let's say, which is right now 9600 hertz is our threshold. Anything below that is going to be fine. Nothing's going to be touching it, depending on your slope, of course. But anything above it is going to be cut or drastically reduced, depending on the slope that you choose. Now these bottom numbers here, this is the Q slope. What this does is this adjusts the severity of the cut. So say you want to cut right here at 280 hertz, which is a good move to make when you're mixing. That takes out the muddiness, that's great. But say you want it to be a narrower cut. You really found a trouble spot, but you liked the warmth and the bassiness of your mix, but you just wanted to take out just that muddiness, and you found that perfect frequency that's like causing all the trouble. Then you can just take this cue and move it up. And the higher the number goes, the smaller it gets. It is recommended by many people, you'll read this in many places, that narrower or higher cues tend to be better for cutting. They say it sounds the most natural. Whether that is the case is totally up to you. It's totally subjective. But when you're cutting, you want to cut narrow. But when you're boosting, you want to boost wide. And something that I found that I like is that you can cut more than you can boost generally. So what that means is like that this narrow cue at negative 7.5 dB is going to be much less audible to the ear in whatever your listening situation, than this maybe not one, but yeah, even this 2.5 dB boost at 1.2K. You can cut more than you can boost because of the way that it changes the sound. So this is our EQ. This is our basic. This is basically it. There's tons of presets, really good presets actually. So the best thing you can do is just sit and play around. Like get a sweet performance, take a really awesome take, and just play around with it. See what feels right. Grab a couple of other instruments, just make a really quick demo track and just play around with this stuff and like see and like make your own mix. Do what you can with it. I guess a couple of last things. You can bypass the EQ if you want to hear the complete difference on what you're doing with your EQ and your... Well, thanks guys for sticking around in this tutorial. I hope you had an educational time. These other things, we did go over the analyzer. We'll go over this stuff in another episode. This is a little bit more advanced, but this is the basic EQ that Logic offers, and it's really, 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 really good. You could not ask for a better stock EQ. It's a really easy user interface. Sometimes other DAWs like to use the skeuomorphic design of the actual knobs and everything, which is also really cool, but Apple has recently gone more for this just basic graphic design as in the box becomes the standard. But yeah, I hope you guys had a great time, and there are going to be many more sessions to come and more tutorials. All right, guys, have a great night. Please, please, please hit subscribe and be sure to make your music and make it passionate and make sure that you love doing it and that you have as much fun as possible through every single process and step of the process of making music. All right, guys, have a great one.